All right, so next thing we're going to do is we're just going to clean up the hierarchy a bit here and make some walls for our level. So what we're going to do is we're just going to right click here in the hierarchy and we're going to create an empty and we're going to name it map. And we're just going to reset the transform here so it's in the middle. This is just an empty game object that has no components other than the transform. We're just using it for organization purposes. So what we're going to do is we're going to drag our floor game object underneath our map game object so it's a child. Then we're also going to now, underneath our map, we're going to right click, we're going to create a 3D object, a cube, call it wall, and we're going to bring that up to the surface and move it forward like this. And this is going to be a wall here, so let's make it wider on the X, so let's make it like 4 on the X, 5 on the X, there we go. Now that looks like a wall. And let's also give it a material here. So in our materials folder, right click, create material, wall, drag that onto our wall, give it a bit of an orangey brown here. Go. There, now we have a wall. Okay, the next thing we want to do is we want to make our enemy that we're going to have to, dodge. So for that, let's just move our player back a bit here. And let's right click in our hierarchy and we're going to create a 3D object, cube, call it enemy. Okay, and we're going to reset its transform and move it up. So it's right in the middle of our scene on the ground. And we're going to make a material for the enemy. So in our materials folder, right click, create material, enemy, and drag and drop that on the enemy. And pick a good red color for our enemy. It's good. All right. And now we are going to actually have to program our enemy so it moves around our map. So for that, we're going to go to our scripts folder, right click in here and create another C# script and call it enemy. And hit open this. Don't want to do that yet though. And what we're going to do is we're going to drag and drop this script onto our enemy game object here, the inspector, or you can drag and drop it on the enemy in the hierarchy. Let's drop it in the inspector here. It's our enemy script. And now I'm going to open the enemy script so we can modify it. Okay, so here's our enemy script here. We're going to actually delete the start function because we don't need that function. And we're going to start again by making some variables we need. We need a public float move speed. Pretty straightforward. It's a float for our move speed. A public transform array. So for that, it's the transform variable type, and then these two square brackets to make it an array. Waypoints. So this is an array, so that means it's multiple indexes of it. So this is going to be an array of waypoints, and they're of type transform because if you remember, the transform is the position in the world, position, rotation, scale. So that is going to be our array of waypoints because we want our enemy to move between multiple different waypoints, right? And then we need one more variable here. Let's make it a private. You don't need to modify it in the inspector. Int current point. So this is going to be the current waypoint that we're at because you're going to need to keep track of what waypoint we need to go to next, right? All right, so that's all our variables. So now in our update function here, we're going to write the logic that's going to actually make our enemy move between waypoints. So what we want to do is we want to move our transform.position. So this is our position of the enemy. And we're going to make it equal to a vector3 dot move towards. So this is a built-in function for vector3. And you can read here if you mouse over at what it does. It basically moves the position from where the current point is to a target point at a delta. So what our current position is our transform.position. And we want to move towards waypoints at current point, index current point dot position. So we want to move from where we are right now towards the next waypoint, or the current point, dot position. And the rate that we want to move at is our move speed, and we want to multiply that by time dot delta time. And so our move speed is, just the variable we set in the inspector, and we're multiplying it by time by delta time because this is the amount of time that's passed since the last frame. So this just ensures that we are moving at a constant rate, no matter what our frame rate is. So we just want to make sure we do that. So that's literally the one line of code we need to move cube from one position to another position. And the next thing we need to do is we just need to keep track of when we've reached the waypoint and tell the enemy to now start going to the next waypoint. So to do that, we just want to check if we have reached the current waypoint that we're moving towards. So if transform.position is exactly equal to waypoints, the current waypoint we're going to dot position. So if our current position is exactly equal to the waypoint that we're going towards, then what we want to do is we want to tell it to go to the next waypoint. So current point plus plus. And what this is going to do is just going to increment this value, which is the index we're checking for in this waypoints array. And this is just going to increment. But the issue right here is it's going to increment infinitely, and it's going to do actually a out of bounds error eventually. So what we need to do is we need to just check if we're at the last waypoint. So if our current point is exactly equal to waypoints dot length -1, because arrays start at 0 index. So if we're at the last waypoint, we just want to set our current point back equal to the first index of the array, right? And then otherwise else we want to just increment it normally if we're not at our max waypoint yet. And that is all the code that we should need for our enemy script for now. And yeah, so now we can just Control S to save our file save, and then we can close that. And back in the Unity inspector here, we just need to set up our enemy script here, and we need to make sure we set all the variables here in the inspector. So the first thing we're going to do is we're going to set the move speed to 2.5. I know that's a decent move speed. And now for this waypoints array here, you can see this is an array. There's size 0 right now, and we can click this plus and add more elements to it. So now there's 2 elements, and they have none transforms. We need to actually make these transform objects in the world here that we're going to drag into here. So for that, we're going to right-click in the hierarchy, create an empty, call it waypoints, point holder, just call it waypoints. We're just going to reset its transform so it's in the center. And underneath this, we're going to right-click on it, and we're going to create another empty, and we're going to call it waypoint. And this is going to be our first waypoint. You can see right now it's right in the center of the world. We're going to move it up 0.5. So again, control click to move it up, snap it up on 2.5, 0.25 increments, or you can just type 0.5 here in the Y. Now you can see it's right in the center of the cube, which is what we want because that's where the position is moving from. What we want to do is you just want to move it off to the side here somewhere, because we want the cube to say move back and forth. So that's our first waypoint. Then we're going to need to make a second waypoint. So to do that, we can, with it selected, do Control D. It's going to duplicate it, and we're going to again move this waypoint somewhere to the left here. Now you can see we have 2 waypoints, one over there on the right and one over here on the left. What we're going to do now is just back on our enemy game object in the enemy script component here, we're just going to drag our 2 waypoint transforms into the element 0 and element 1 of this waypoints array. So you can see waypoint and waypoint 1 is now in that array on the enemy script. And perfect, that should be all we need to do. And so now if we Control S to save and click play, should see, yes, our enemy is moving side to side. But if we sit in our enemy's path here, nothing is going to happen because we haven't set up the logic to actually be able to die as a player. That's what we're going to do next. Pushing us along. Let's stop the game. And let's move on to player death. So the first thing we're going to do is we're going to need to have some way of detecting that we've actually touched the enemy. And to do that, we're going to use something called tags. And that is up in the top right here in the inspector. And when you have the enemy selected, underneath tag here, you can see it's untagged for now. What we're going to do is we're going to create a tag. So for that, click on this drop down, click add tag. And in this tags list is empty. We're going to click the plus, add a new tag called enemy. Save that. And then we're going to click on the enemy again in the hierarchy, click on this tag again here, and now we see enemies in this drop down. We're going to click on that. And now this enemy game is tagged with enemy. And now, since this enemy has a box collider, we can actually detect when we collide with this enemy if we set it to the is trigger. So let's just do is trigger here is checked in the box collider. Make sure is triggers selected. And now what we're going to do is we're going to actually write the code to detect this collision and make the player die. So to do that, we're going to go to the scripts folder, go to the player script, double click on that to open it. We're going to make some modifications to this script. The first thing we're going to do here is we're going to need one more variable, private bool is dead. And this is just going to be a variable we're going to use to check kind of like a state if we're dead. But yeah, is dead. And what we're going to do here is in the fixed update, we're just going to do some safety checks here. And if we is dead equal to true. So if we're dead, we're just going to return. What this is going to do is if we're dead, it's going to return and it's not going to execute any code after this. Return basically just exits the function, or in this case, goes to the next loop because it's a fixed update. So none of the movement code will run if we're dead because we don't want to be able to move if we're dead. That's just a good safety check there. The next thing we're going to do is we're going to actually detect that collision with the enemy. And to do that, we're going to need a new function here, kind of a built-in function. It's called private void. It's called on trigger enter. And you see it auto-completed there on trigger enter. And it's giving the variable collider other. I'm going to rename that to col. And this is basically going to, whenever we touch a collider that has a trigger on it, it's going to call this function giving us the collider component that we've collided with. So now what we can do here is in this if statement, we can do if, make an if statement in here, we can do if call dot tag is equal to, remember we named it enemy. So if the collider that we've collided with, if the tag is equal to enemy, then we can do what we want to do here. And what we want to do is we want to call another function that's going to do our dying logic. And for that, this is going to be a special function. So we're going to type start coroutine, and we're going to name the function die. And remember I said this is a special function, so we have to use start coroutine to call it, because this is a special type of function. Let's make it here public enumerator. Oh no. IEnumerator. I missed the I. IEnumerator. There we go. I never remember how to spell that. And die. And this is a IEnumerator function or a coroutine function. And basically this is a special type of function where you can do waits, where you can wait for time to pass. Because what we want to do is we want to yield earn new wait for seconds to 2 seconds. So we want to wait for 2 seconds. This just waits for 2 seconds. Because after we die, we want to wait for a second, 2 seconds, before we restart the level. So before we die, though, or right when we die, we want to actually, make it known that we've died. So we want to do a few things like turn off the player mesh renderer so we don't see the cube anymore. So for that, we can do get component mesh renderer dot enabled equals false. So this is going to turn off the cube mesh renderer so we can't see it. If we go to the inspector here and kind of do it manually here, if I turn off the mesh renderer, cube disappears, right? And the next thing you want to do is you just want to do rb dot rb dot constraints equals rigid body constraints dot freeze all. And what this is going to do is it's just going to freeze the physics on the player so that it stops moving, because when we die we want to stop moving, freeze in place. That's all that's going to do. Okay, and also before we die we want to set is dead equal to, or right when we die, not before we die. We want to set is dead to true, and also if we're already dead, we want to return, and it's actually yield break, I believe. Yield break, yes. So if we're already dead, we don't want to call the code that is run when we die again. So we're just going to do a safety check there. If we're already dead, yield break does the same thing as return in this function. It just stops and doesn't execute any of the code afterwards. But if we're not dead yet, we're going to set that we're dead, turn off the mesh, freeze our rigid body. Then we're going to wait 2 seconds. And then what we want to do is we want to load the scene again, reload the scene, reload the level, right? So for that, we need to bring an extra using into our code here. So this is just extra libraries that you bring into your script. So we need to use the Unity engine dot scene management library. So yep, because this scene manager requires that library. So scene manager dot, we want to load scene, and we want to load basically the scene that we're on right now. So for that we can do scene manager dot get active scene dot name. There you go. This is just going to reload the currently active scene. Perfect. So yeah, that is all the code we need for detecting colliding with an enemy and doing all the die logic. So now I'm just going to Control S to save and minimize this. And now if we save the Unity editor as well, Control S, and play, we should be able to now run into the enemy, oof, and we die. And the scene reloads, see? Now one other thing we want to do is I think we probably want to make it so we die if we fall off as well. Otherwise it'll just go on like this forever, right? So to do that, if we reopen our player script here and we go to the fixed update, we can just do right at the bottom here, if transform.position.y. So if our position on the y is less than -1, which is basically falling off the map, then we can just do our start coroutine die once again. So this is just going to start our die coroutine if we fall off the map. Control S to save that, minimize this. And back in the Unity editor, we click play. And yes, now we can jump off the map and we die. Perfect. Okay, so the next thing we want to do here is I think we just want to add a little bit more, pizzazz when we die. Because right now the cube just pops out of disappearance. But I think what we want to do is we want to add some particles. Now, for that, what we want to do is we want to use a Unity particle system. And what you're going to see here is there's going to be a lot of options in this, but it is a very powerful system. So to do this, what we're going to do is underneath the player here, we're going to right click. We're going to create a effect, so effects particle system. And this is the def parts, we can name it. You can see here, it's already kind of playing automatically. And here in the inspector, you can see, yes, it has a lot of options, like I said. So for this tutorial, I've already got the options all figured out. I'm going to say exactly what to do, so you just, For the video here, you can pause and watch exactly what I click here and input. But on your own, you can of course go crazy with editing all these settings, and you can make some really cool things with particles in Unity. So the first thing we're going to do is on the X rotation, we're going to do -90, so it's pointing upwards. We're going to looping, uncheck looping. We're going to set the start lifetime here, random between two constants. To do that, you just click on this little arrow, random between two constants. 1 to 2. Same with the speed, random between two constants. 3 to 5. Start size, random between two constants. 0.1 to 0.3. Gravity multiplier, 1. Play on awake, uncheck that. Now under emission, we're going to set rate over time to 0, and we're going to make a burst here, click the plus, and we're going to set the count to 10. Now underneath the shape, we're going to set the radius to 0.5. And now lastly, under renderer, we're going to set the render type to mesh. We're going to set the material to the player. For that, you just click this little circle here and find the player material, player. And we're going to set the render alignment from view to world. And there we go. I just sped through that, but again, hopefully you can pause the video to set all those settings. And now, if you can see this little gizmo here, we can actually test it. You can see if we click play, it spurts out these particles as if we've died. And now what we want to do is we want to make this actually happen in the game. So to do that, we just have to write a little bit of code here in the player script. So let's open the player script. And in the player script, at the top here, we just need another variable. Set. We're going to make this one public. Public, because we need to set it by the inspector, and it's going to be a particle system and death parts. We'll name it. There we go. Public particle system death parts. And now what we need to do is just in the die coroutine here. Right after we do the constraints here, we're going to do death parts dot play. We call the play function, which is basically just going to make it play. Okay, so Control S to save this, minimize this, and in the Unity inspector, what we're going to do is on the player component, on the player game object, under our player component, you'll see death parts right now has none, so we have to drag our death parts. To do that, we can just click and hold on our death parts game object and drag it into here, and it automatically grabs the death particle system from it as a component. Perfect. So now our death parts are in here. Control S to save. Play once again, and now when we die, our cube should explode. Yes, there we go. We got death particles. Perfect. Cool. So that's the particle system. Like I said, very powerful system. Lots of settings you can mess with, but hopefully that's a nice quick introduction. All right, next up, what we're going to do is we're just going to set some lighting settings just to make it look a little bit better here. Because if you see right now when we play, it's a little bit dark. Shadows are a bit dark, and the background's kind of boring. So what we're going to do is, first off, we're going to fix the background. So for that, we just go to the main camera, which is underneath our player here. And we're going to set the environment here. Under environment, we're going to set the background type from skybox to solid color. And we're going to set it to a nice blue. You can see the preview here in the bottom right of the scene. Nice sky blue. Happy little sky. That looks good right there. And that's the sky. The next thing I want to do is just make these shadows look a bit better. So for that, we're going to mess with the scene lighting, and for that we go to Window, the top here, and we're going to look for lighting. It's under rendering. Yep, rendering, lighting. Open this little window. I like to dock it here beside the inspector. And these are a bunch of settings don't need to worry about. Underneath the environment tab, there's one setting in here that we want to worry about, and that's under environment. We want to set the source to color, and then this color we also want to make about similar to our our sky, a little bit darker. And you'll see here, if you look in the scene, it's kind of modifying. It's giving it a bunch of light as if it's coming from the sky. I think it just looks a lot better. Again, you can mess with these settings and colors, and you can get the look how you want. But for now, we're going to modify that one color. And now if you play the game, it should look a lot better just with those two simple settings. You see the lighting looks a lot better. Shadows aren't as dark. Sky looks like a sky. Awesome. Oof. Okay, that's lighting. The next thing we're going to do here is we're just going to talk about prefabs, what they are, and why we use them. So to create a prefab, and what exactly is a prefab? A prefab is basically similar to a scene, but it's for a game object, and this game object can then easily be edited across multiple scenes and locations. So if you have multiple instances of the same game object, it's probably a good idea to make a prefab for it, so that if you edit the settings in one place, they're modified in all places. So to create a prefab, so I can better explain it, what we're going to do is we're going to go to our prefabs folder, make sure that's open. We're going to click and drag our player game object from our hierarchy into this prefabs folder, and you see it makes this player prefab. And if we double click on it here, you see it brings it into this like isolated scene view where it's just our player. And if we go to the inspector here, you see it's all our player stuff. It's the main camera that's underneath our player and the depth parts that are underneath our player. So this is the prefab, and any settings, any changes we make to the settings here are going to be made. You can see it shows up as blue here in the scene. It's going to be made to this game object as well. And what the usefulness for this is that in a minute, next thing we're going to do is we're going to make multiple scenes. And so now when we change it in here, it's going to change in every scene. And so you got to make sure that if you want to make modifications to the player, now you shouldn't do it by just clicking on it here and clicking in here, because any modifications you make here, you'll see has this blue line beside it, which means that it's only for this scene that you're making these modifications. So if you want to make modifications, what you really should do is you should either double click on the player in your prefabs folder, or you can click this little arrow here, which brings you to the prefab view. And you can see here it made everything in the background like white and grayed out because you're focused on the player right now, and any modifications you're just making are to the player. All right, so now we're going to do the same thing for enemy. We're going to make an enemy prefab as well. So we'll just drag him into the prefabs folder because we're going to have multiple enemies and we're going to have them across multiple scenes. All right, so that's prefabs, and we'll use them a bit more. So hopefully you'll get used to how exactly they work as we use them. Next thing we're going to do is we want to actually make a goal for our player to have to get to, and then that is going to bring us to the next scene. So to do that is we're going to right click in our hierarchy once again, create a 3-object cube, name it goal. We're going to reset its transform, right click reset, move it up while holding control so it snaps. We're going to put it back here, and we're going to make a material for it, material folder, right click, create material, our goal, drag it onto our goal cube here. We're going to give it like a green color, but more bright so it stands out. And also we're going to make it slightly transparent. And to do that, what you can do is you can set the surface type from opaque to transparent. And then what you can do is in the color, you can lower the alpha. We'll lower it to like 200. There we go. And then now, I like look at it from this angle. You can't really tell, but yeah, there you go. You can tell there. You can see through it and see the cubes through it. Okay. So that is our material. The next thing we need to do is because we need to collide with this, we need to also add a tag for it. So for the tag, let's do again the same thing we did with the enemy, add tag plus goal. Save that, click on it again, and click on the goal tag. All right. Before we move on here, let's also make this goal a prefab because it's going to be in multiple scenes. So drag that into the prefabs folder. And then this is going to showcase making modifications to it. We need to make sure that, again, we click on this little arrow here so that we're in the prefab view. Because we need to collide with it, we're going to need to use that on trigger again. So we're going to set it, the box collider here in the inspector to is trigger true. Perfect. And now that should be good. Next, we're going to go out of the prefab view there, and we're going to go to our scripts and our player script. And in the same location here, on trigger enter function, where we check if we're colliding with the enemy, we're going to do else if call.tag equal to goal. So if we collide with the, remember we named it goal, what we want to do is we want to essentially go to the next scene. So for that, let's write some code for that. So first things first, we want to get the build index, and I'll get into what the build index is in a minute, but we're going to get the build index and set it equal to scene manager dot get active scenes, the current scene that we're in, the current build index of the current scene we're in, and we're going to increment it by 1 because we want to get the next scene build index. And we're going to just do a check here if the build index is greater than or equal to scene manager dot scene count build settings. So if this is checking to see if the build index that we want to go to next, if it's actually greater than the amount of scenes that we have in the project or the build settings, then we don't actually want to go to the next scene because there is no next scene. We want to go back to the first scene, right? Which, you know, in a finished game would be like the main menu or something, but we just want to go back to the first level. And so then what we want to do is after we've set all that up, is we want to actually go to the scene that we've chosen. So load scene, build index. So this is going to actually change the scene to the build index that we've selected. Now, that's all the code that we need to write now. I've been talking about this build index. What is this build index? I'm going to go show you right now. So let's minimize this, save and minimize that. And if we go to our scenes folder here, we see that we have this sample scene that we've been working on. We're going to actually now make multiple scenes. So we're going to rename the sample scene to level underscore 1. And then we're going to click on it and do Control D to duplicate this scene. And we're going to rename it to level 2. So now we have 2 levels, level 1, level 2. Now, each one of these scenes has a build index. And to see what that is, we go to File in the top left here, Build Settings. You see here, right now we have scene/level 1. And this 0 right here is the build index. So this is build index 0, level 1. And you notice level 2 isn't here. So how we do that is we need to click this Add Open Scenes button. But you see it doesn't do anything because right now we have the level 1 as the open scene. So let's open level 2. Now we have level 2 as the open scene. And now click Add Open Scenes. And now level 2 shows up here, build index 1. So now the code should hopefully make sense. Starting at build index 0. And then 0 plus 1 is 1. So we'll go to the next level. And then 1 plus 1 is 2, but there's only 2 levels, so that's going to now overflow, so it's going to go back to 0. All right, hopefully that all made sense. So let's go to level 2 here, sorry. You can double click on this scene just to open it, and you can see that it's switched here by the name at the top of the hierarchy. See, level 1, level 2. And you see, like, I'm double clicking between them. You couldn't even tell the difference, so let's just move this wall over here and the goal over here. I'm holding control, by the way, while clicking on this green cube, which makes it move along the plane here, the flat plane. The XZ plane is what that yellow cube makes it move. Yellow square makes it move along. So I've just changed up the scenes here. And now if I switch between level 1, gotta make sure you save the scene before you try to switch. Level 1 and level 2, you see it's switching. This is level 1, this is level 2. All right, and so let's also just in level 2 here, let's change up the enemy here to move like in a triangle. So waypoint 1, let's actually move back here. Waypoint 2, let's move up here, and then let's make a third waypoint. So click on it, Control D, put it over here. So it's going to move in like a triangle pattern. And we just got to make sure we add that third waypoint to the enemy game object here in the enemy component. So that. Cool. And now if we just save and we go back to level 1, we play. And if we actually now go and touch our goal, remember we added the logic so that when we touch the goal, it loads the next scene. And there we go. Now we're on level 2. See our enemies are moving in a triangle pattern. And the wall's over here. Perfect. We can go to this. And it goes back to the first level because we only have 2 levels. Perfect. So that is our, our basic cube game with our enemy and our goal to load the next level and our player death. Awesome. So yeah, that is the first GDYU Unity workshop. I hope you're able to follow along. And yeah, thank you for watching.